Um, I have brought an agenda consisting of 4 items. First, we will have a look at 2 concrete case studies. Then we will see the GitHub account of the International Actuarial Association, where we collect, host, and develop case studies in the field of actuarial AI. And at the end, if there is some more time, we will talk about the AI Taskforce, which produced this GitHub and many other stuff. Okay. First of all, I am going to talk about use cases which are located in the area of generative AI. So large language models and how they can help us in our actuarial practice. The first one is about using large language model to extract information, to extract data from unstructured texts. The goal will be, well, we have a machine learning framework. We want to predict how many claims we have to, how much costs we have for separate claims. And we have this setting that we have predictive signals which come from a table. Tabular data where we have most of the time just numerical features. There is one column which describes the accident which led to the claim. For example, in this claim description column, you see a stone fell from a roof and hit the person on his head. This should be a more severe damage than if you just cut your finger with, uh, some scissors, for example. So the idea will be use a large language model, extract relevant information from this claim description column, and in the best case, you can use the extracted data to improve the machine learning prediction. We have implemented this on a basis of a synthetic, publicly available data set, which you can find in the links later on. A couple of thousand of claims descriptions. And what we did was to extract 3 separate features. The first one is what was the main body part which was injured. Was it the head, some fingers, the foot, the back? What was the cause for the injury? Was it because of some burning, because some burning liquid was thrown at the people? Or how many body parts are injured? Just one, the head, or are there 3 different parts involved? As you can imagine, by simply using a free-form extraction, using a large language model, this will lead to quite a lot different categories. Also, maybe someone, it's the head or the upper body, or do we have to put all of them into one category? So the next step was to condense the information into 8 regions for the body and 13 categories for the cause of the injury. So just to condense it and to make the task for the machine learning gradient boosting models later on a little bit more easy. The results are promising. In our data set, we indeed found that using those new features which come from the LLM extraction yield an improvement in prediction. To give you a few numbers, we have 80% decrease for root mean squared error. Decrease is good in this one. Also for the mean absolute error and some improvement for the R squared. And what we also could do is to allocate this improvement to our 3 new features. And what we found out was that it's not the number of body parts injured, but the main body part which played the most crucial role. So large language models were used not to do the calculations, but to do what they are good at, that is using text, unstructured data, and summarize, generate new texts. And in this part, in this case study, we use it to extract. The next case study is on coding. I guess almost every actuary should be aware that programming is a good skill, and at least have some programs which are there in the company or at the client. What is bad at having codes is that they can become old. For example, modern technologies like COBOL, SAS, R, or VBA get outdated and then have to be migrated, that is transformed into more modern programming languages, like for example Python in this example. The example I've brought with me is on using large language models to migrate existing R code into Python. That is all the data inputs, data outputs, interim result printings should be converted into a Python program, and all the functionality should be preserved. Also, the numbers, all the results that are produced should be verified so that it's not only a nicely looking translation, but indeed validates so that they are equivalent. To make it a little bit more fancy, let's not only use large language models, but let's use agentic AI. Agentic AI in the sense that I have set up a multi-agent system. That is, I will not use one single large language model, but I will use in total 5 different large language models, each with different intelligence. Sometimes I need very powerful models. Sometimes I only need some quick and dirty models. And all these large language models are equipped with some tool callings. So they might access a database, or the R analysis agent might have the ability to read some files, or the test runner will be able to validate using a deterministic function, which is standard for validating Python code. So in total, we have a multi-agent system that you can see on the right-hand side, consisting of 5 different agents. One, which is initially for analyzing the code that we are dealing with. Is it a hard code, a long code? What are the main functions? What are the inputs? What are the outputs? Then we have a translation agent. This one is good at translating R to Python and also has some system prompts with it, some instructions on how to translate certain things or how to a compilation agent, which is for synthetically verifying that the translation compiles. Then a very important one, the test runner. This one is for validating the translated code against a test suite that we have set up in advance. For example, you can set up 10 to 14 tests which check whether there are some the dimensions of the data tables are equal in R and in Python, or also to have some semantical validation. That is, are the numbers correct? Are they correct up to the 4th decimal point? And the last one, not really needed, but cool in productive environments, is the report agent, which produces a nicely looking report consisting of different things that he found during the migration. What were the hardest challenges? Are there some ambiguities which were resolved in one or the other way? And at least it will be noted down here and described. And give you just a one pager on what was done and how many tests were successfully run and many other things. About the testing and the compilation, you might see those dashed arrows. It's a multi-agent system, so you can have connections between the different agents. It's not just pure sequentially, but in case that one agent fails, for example, the compilation agent or the test runner agent, then we will have a feedback loop. The test runner agent might say, okay, you passed the first 4 tests, but in test 5, I got an error. Please not only revise the translation, but also incorporate and use the information that you find in this particular error description. So having the previous translation and the error description may help the large language model to produce a better translation so that in the final end, the test runner is satisfied and all tests pass. This works quite well. Very easy setup, I guess. Claude Code and the like are way more powerful, but for demonstration purposes and to see and how to set up such multi-agent systems, it's quite valuable for actuaries. And because we do not want to keep this hidden away in our secret chamber, we also have shared those case studies in the GitHub account of the International Actuarial Association. Let me just show you how this might look. We have not only an article on this, but you find the complete code in the GitHub. Not only in the GitHub, you find the code, which is quite okay for passive reading. You might check how certain parts were implemented, but I think it's way cooler to explore it actively. That is, that you have the possibility to run this code on your own machine. And in order to run this on your own machine, you do not even have to install things. You are allowed to, for sure, but we have included some badges, and after clicking on one of those badges, the Jupyter Notebook, the whole code is opened in a platform which runs the notebook so that you do not have to install anything. Let me just run this notebook until where the magic happens. That's down here. You can just run everything until a specific cell. And what I want to show you is those large language models, those agent, the 5, they have to be set up. You have to tell them what tools they're allowed to use. Are they allowed to access a database or to read files? And you also have to instruct them. That's the main challenge, and you have to build up some experience on how to set them up. For example, the report agent has a middle long system prompt, and in case you cannot read it, I'll just mention the most important things. For example, you can tell him that it should follow a specific structure. Each of the migration reports should have section 1, 2, 3, 4, 5, 6, consisting of the information that I want to have it in. For example, the first section should always be the summary. You should also tell him which model to use. For example, report generation is not that tough, so I can use a mini model from OpenAI GPT-5.4 Mini. For the translation, which is more of a hard task, I will switch to a more powerful model like GPT-5.4. I will not go through every agent separately. You can have a look at this afterwards. Let me show you how this works. So we have set up this multi-agent system structure, and now let's run the pipeline. The input is an R file on reserving, and you may see there are some comments and R specifics in there. You do some calculations, and at the end, you want to calculate some ultimates for such a reserved triangle. The input data is in a CSV file and should be imported at the beginning, and then let's run the whole pipeline. I tried to include some interim results so that you can see at which part the system is currently working on. We have now step 1, the R analysis agent, which reads the input file and checks its internal structure. We will also see some token count so that you can more or less estimate how costly this translation is. For this simple example, we will have a few cents, I guess. Then we see that the translation agent gets some information from the R analysis agent and will do the hard work of translating. In this simple example, it is quite probable that it will go through in just one run, that we do not have this feedback loops so that the code is generated at first try. As you can see here, the compilation one says pass, and then the test runner, which was given 14 tests in advance, also is quite happy that all of the 14 tests passed, and then the report agent is quite fast at generating the migration report. So we're done. Hooray. Let's see what the migration report tells us. First of all, comparing numbers. Well, let's go directly into the, where is it? The migration report. So we see the 6 sections. First, the summary, what the R script does, then the translation approach, like this read CSV file in R has an equivalent in Python, which is based on pandas, and many more. Some special handlings or some challenges that it identified. Information on how many times was each of the agents invoked, how many retries did we have, and at the end, the test results, what was verified against what, and did it pass or not. This is indeed a case study which finds its way into production. Currently, I'm working on a large multi-million project on migrating SAS to Python. And it's not only a technical case study, but in order to migrate code, you need to understand what it is doing. So the actuary remains as a domain expert. He or she brings that domain knowledge and also has this technical experience that is needed to build or validate such a multi-agent system. All right, from those case studies on to the AI task force. You will find some additional information about this AI task force either in the remaining slides of this presentation that you will be given after this event, or also you can ask some of the AI task force members, which are also in the room right now. Jackie and Chadwick, I guess. I already have seen Jackie. Ask them. Very cool initiative, this AI task force. And one of the main deliverables of the task force is to produce a GitHub page where actuaries interested in artificial intelligence can get some inspiration on case studies, not only on a theoretical level, but also most of the case studies are implemented so that you can grab the code, modify, download, and use it for your own purposes. The GitHub website, well, let's make it even more live. This is the GitHub account, github.com IAITF, consists of 2 repositories. One is on case studies and one is on tools. Tools are not with a specific actuarial purpose, but serves more as a repository where we can store guides and tutorials which are on tools which are not designed primarily for actuaries, but will help actuaries in their daily work. When we jump to the repository on actuarial AI case studies, then we have 2 different things in here. The first one is this case study catalog. It's not only the AI task force which produces cool case studies, but there are plenty of individual actuaries or also companies around the globe which have such interesting case studies which are unfortunately distributed at very, very different channels. Some Actuaries have their own GitHub. Some are just as an appendix in a scientific article. A few actuarial associations have their own GitHub, but as you can imagine, there is plenty of sources of case studies. So our idea and goal was to group and collect and compile them into one case study catalog. We are not taking away the contents, we are just linking to the sources where they lie. For example, we have an individual, which is also in the AI task force, which constructed in his free time a case study on Florida flood insurance, where he tried to predict which areas are affected more severe using not only traditional models, but also some spatial embeddings, and sees whether this helps in predicting. We have a lot of metadata for each of the case studies, not only for the person and the date, but also which topics are covered from this specific case study. And also at the end, an abstract so that people who not only read the title and want to dive a little bit deeper into it, get an idea on what this case study is all about. I didn't count them, but we have a couple of dozens, so I would say 40 case studies, which cover different areas. We have life, health, non-life. We have some educational case studies. We have some expert case studies. We have case studies which have articles and corresponding notebooks. Some are in Python, some are in R. So quite a good collection. So if you want to find some case studies on a specific topic, there is not a search button directly in the GitHub, but you can, for example, search in the web, or even when you search on your favorite web search on the internet, or use some large language model search tools like Perplexity, then this GitHub account of the AI task force is already recognized and typically ranked among the best first results. So in this case study catalog, this was the one thing. And the other thing was the case studies that we developed by ourselves. They are stored in separate folders. For example, you see this code migration case study that I presented a couple of minutes ago in here, where you find all information needed, all the inputs, the tests, the Jupyter notebook, but also some information on how to start and run the code, either via the badges or some instructions are given how to download it. Just in case you're curious about how can one run large language models without installing them or having your own API key, this is indeed mandatory. So you have to have a large language model API key in order to run the large language model case studies. All right, back to the slides in the last 2 minutes. A few more information about the IAAI task force. We started in end of 2023 or beginning of 2024 with the idea to make the profession better, advance the competency of the profession. Also to promote the role of the actuary and to get in contact and in touch with other associations about AI topics like supranational regulatory bodies or alike. We have 4 work streams, and to make it a little bit more tangible what the work streams are doing, just as a selection, we have set up a platform on AI for actuaries with the same name, a platform where actuaries all around the world can talk to each other, discuss, share knowledge, do some polls. We have over 2,400 members so far, so if you do not know this website, give it a try. We have seen the GitHub account, and one workstream is producing some very informative papers. They already published on the IAA website 3 papers on artificial intelligence, governance, testing, and documentation. 3 more are to follow in the next weeks, and they are already producing and working on some more.